love to hear that. A full silent room immediately. Let's do a round of applause for everyone for spending time here with us tonight. I could not be more excited to welcome you all on to tonight's event, Boundary Breakers, a showcase of critical technology innovations in national security. It's an incredible night for us here during DC Startup and Tech Week. It's the 10th anniversary of this program, of this type of program, these weeks of innovation. As someone who's been in the community for over the last 15 years, it is truly nights like these that become lasting memories for people, that really become these catalytic moments, bringing communities together, connecting entrepreneurs, and really feeling that energy. By the moment I came on the stage, I could hear the pin drop. I know everyone is very ready and excited to hear from each of these entrepreneurs tonight. To frame us up for a second, I want to introduce myself. My name's Margaret Roth. I was a co-founder of a dual-use data analytics company. We got started in 2015, or really in 2013, but 2015 was sort of our breakout year. So I've been on a 10-year journey myself as well. Today, I get to spend most of my time with founders of dual-use technology companies as principal at Squadra Ventures. It's incredibly special to get to work with entrepreneurs at this kind of phase of their careers and in this part of their stories. Tonight, we're going to really take an exploration through a few different critical technology areas that not only are we investing in at Squadra, but they're coming from innovators from the lab. They're coming from innovations across universities in our area like Hopkins and beyond. As a Hopkins Blue Jay, though, myself, I could not be more excited to actually have a few fellow alum on stage tonight and share with us and many other alums who are here tonight in this incredible facility. So I want to give a shout out to the Hopkins Bloomberg Center, first of all, for hosting us. Round of applause for them. Thank you so much. And I'm actually going to go ahead and recognize that there's a couple areas we're going through: critical minerals, autonomy, communications, microelectronics, and manufacturing. We're going to go across the board as we see tonight's speakers. Each of them are going to tell us their story. Tonight, as we've shared, we're prioritizing passion and plot twists, focusing on the storytelling of their journey and less about the pitch. Before we get started with welcoming our speakers, I'd like to welcome Myra Norton to the stage. She's the head of innovation for startup and ecosystem acceleration at our partner for this event, Johns Hopkins Technology Ventures.
Thank you, Margaret. Good evening, everyone. Good day at DC Startup and Tech Week? Yeah? Okay. I want to start by welcoming you to the Johns Hopkins University Bloomberg Center. Pretty incredible place, isn't it? Yeah, how many of you, this was your first time? Yeah, well, welcome. This place is really special. It is this combination of public square and incubator sitting here at the steps of government. It is a place where we convene private sector, public sector, academia, investors, entrepreneurs, all to launch incredible ideas, game-changing companies, transformational policy solutions. So we're all really lucky to be here tonight, and I hope this will not be your last time here. I hope you'll make this a place that is a destination for you. I want to tell you a little bit about what we're doing at Johns Hopkins Technology Ventures. We are, if I can get this to go, yeah, here we go. Our focus is really taking incredible ideas in academia and getting them out into the world. And I have the privilege of working with innovators and entrepreneurs like the ones you will hear from tonight to support that work. I am a two times entrepreneur myself, and so I know very well the challenging and often lonely journey that entrepreneurship can be. Raise your hand if you're a founder. Keep it up. I want you to just turn around and look at all the hands raised. I do this everywhere that I go. This is your reminder that you are not alone. This is a community of folks who are on the journey or have been on the journey that you are currently on, and we're all here to support each other. So let me tell you a little bit about what we have built here at Johns Hopkins University and how we're thinking about supporting the entrepreneurial journey. A little over a decade ago, the university decided to really create a central hub for entrepreneurship and commercialization. And so at Tech Ventures, we really serve all 10 schools across the university. Whether you are a musician at Peabody that has a business idea, or you're a computer scientist that codes, if you want to get your innovation to market, we're here to help you. Over that decade, I want to tell you some of the things that we've put in place. We recognized 3 critical gaps when we started this journey: space, lab space, office space, a place to park when you need to meet investors. That was missing. We now have 43,000 square feet built to serve that purpose so that our entrepreneurs have a place to work. Funding. Over the last decade, our startups have raised almost $5 billion in venture capital. And then support. We wanted to see more companies spinning out of Hopkins. We have a portfolio now of about 150 startups. Not bad for a decade. The funding momentum, just to give you a sense of what can happen when you galvanize around a central goal, aim. Prior to the launch of Johns Hopkins Technology Ventures, startups coming out of the university had raised about $740 million over the 7 years leading up to our founding, and only about 6% of that stayed in the region. So there were some companies being launched, they were raising money, they were leaving. Since this work started, almost $5 billion raised, and over 50% of that stays in this region. We want to see more of that. We want to see more companies in Baltimore, DC, in the broader DMV region. That also leads to some pretty successful startup exits. So in the 140-year history of the university prior to really galvanizing this work, there had been 11 company exits. In the little more than a decade since, there have been 45. And we're just getting started. Here are a couple of examples of companies that have been sold here in the last few years. Thrive sold to Exact Sciences, PGDX acquired by LabCorp, and Haystack by Quest Diagnostics. When we talk about commercialization and entrepreneurship at the university, we're talking about a very broad swath of stakeholders and entrepreneurs. So we work with faculty, students, alumni, and community change makers. The Pava Center for Entrepreneurship is our student entrepreneurship hub, and this is the place where students and alumni and community change makers come together to launch their ventures. Just to give you a few fast facts, this area for us has been one of extreme growth over the last 5 years. Over the last 5 years, we've had more than 15,000 visits, over 3,000 just in the last year. 2,500 people engaged. This year, we saw 170 teams, and we're awarding almost $1 million a year in grant funding. This is the growth trajectory that the Pava Center has been on. And again, we're just getting started. We want to double down on this work, and we want to see more companies launching, not just out of Hopkins, but in Baltimore, in DC, in this region. In addition to helping these student entrepreneurs launch, we're helping them secure funding. And to me, that is what nights like tonight and the work that we do on a daily basis are all about. It's about supporting entrepreneurs launching their ideas and then getting those ideas funded and helping them do that. So I'm really excited for what you're about to hear tonight. We have an incredible lineup of innovators and entrepreneurs that are doing the hard work that is required to have these kinds of outcomes. I get to share all these great results, but it's really entrepreneurs like many of you who are the ones who deliver it. So I encourage you to sit back and enjoy some really inspiring ideas and stories that you're about to hear. Margaret, I'll turn it back over to you.
Thank you, Myra. Just as Hopkins has been on a journey, we're all ready to go on a journey as well. So as I've already mentioned, we're gonna go take a look at a whole variety of different technology areas. We're gonna get smart on some things that we didn't know about. There's a lot of deep dive technical things that we're gonna go to, but we're also gonna hear the story side of it. And so what better place to start than right here on Earth with a discussion on critical minerals. I'd love to welcome Patrick Ho, President of Forager Station, to the stage. All right, keep that clap going.
Thank you so much. Yeah, thank you, Margaret. Hi, everyone. I'm Patrick Ho. I'm founder of Forager Station. So Forager Station, our mascot is the clam. It's an animal that makes its living from cleaning dirty water. I'm here to talk to you about recovering critical minerals from wastewater today. So a little about me. I founded Forager Station in 2022. And I've been a business owner and entrepreneur for 12 years. I also went to UVA and MIT for mechanical engineering. And I want to start with the mineral water dilemma. So first, what is a critical mineral and why is it important? A critical mineral is something that is very important and hard to replace. So it means that in technology, it's something that just cannot be replaced without severely damaging the function of a device. So for example, the neodymium from a battery, if you take it, the magnetism drops like crazy. You take the lithium from a battery, the energy density drops like crazy. So the US is importing about 53 critical minerals, about to 80-90% of its supply. And this leads you to a second problem, which is we have an import dependence, but we also have something called the mineral water dilemma. When you try to get lithium and make it here domestically, you end up with the problem of 50 tons of water are needed to make 1 ton of lithium. And this means that permitting is actually extremely difficult here. So in the Great Salt Lake, last year, the last magnesium mine in the United States closed due to air quality, water quality issues, and there are several lithium projects that are trying to start up in Utah, but can't because they just can't resolve this water consumption issue. And for Utah, that's about 300 million gallons of water per year in increased demand. There are other projects in California and Nevada. We're talking on the scale of billions of gallons of water. So Forager Station, we propose a solution, which is to process and recover minerals from what I call alphabet soup waste. So these are basically industrial waters that have an alphabet soup of elements in it. So, magnesium, lithium, iron, bromine, strontium, aluminum, gallium, zinc, vanadium, titanium, rare earth elements, scandium, the list goes on. And what Forager Station does is that we have an exclusive license on 2 different types of technologies. So one is recovery electrodes. These electrodes let us process the minerals with massive energy savings and no use of fresh water. And then the second is differentiated membranes to let us target a specific element. So for magnesium, we have a certain set of membranes. For lithium, we have another set of membranes. And I'll be talking about both of these technologies, but I want to sort of zoom out first and get everybody to understand what is the opportunity here overall. So according to the National Energy Technology Lab in Pittsburgh, Pennsylvania, the proven waste resources of lithium and magnesium are actually greater than US consumption. So what does that mean? That means that if we monetize this resource, we can transform from importer to exporter. We can completely flip the entire economic situation. So with lithium, you get about 300% of US demand, and magnesium over 1,000% of US demand. And the best part about this is that you don't need new mines, you don't need new permits. So to permit a mine, you're talking, best case 3 to 5 years, worst case 17 years to get a mine from permit to operation. And this will benefit defense, aerospace, construction, energy, and semiconductors. And for Forager Station especially, we're focused on a magnesium-first strategy. Magnesium can be recovered right now for less than it costs to trash it every year. So we're actually having companies in Texas every year just paying money to trash half the world's production in magnesium. They're hauling it away at, $30, $50 a ton and just taking it to the dump. Like they're literally paying to dump this material. And this is a fairly large market, so we're talking, billions of dollars. For Forager Station, our target market is the electrified water treatment plant system. So in the Permian Basin in Texas, they have a lot of water treatment sites that are electrified, could be set up to recover materials this way. We're talking about a $10 billion market today. They're expecting electrification to proceed, so there will be growth in this market, but as of today, we're talking sort of a $10 billion situation. And the nice thing about brine mineral valorization is this is a very broad-based resource. You know, you find it in lots of states. You don't find mega projects. It's not something that is going to be, you know, one permit makes or breaks the entire supply. This is something that's in Texas and California, in Montana and Pennsylvania. You know, so every corner of the United States has resources that could be monetized this way. So Forager Station is a very small company. It's me and Mario. So I'm founder, Mario CTO. We're both locals. We are based in Frederick, Maryland. Kathy Callahan-Brady is the owner of the incubator in Frederick. And so what she does is she helps startups, especially hard tech startups. So, you know, chemistry, energy, manufacturing, find local boards, local expertise, and builds an ecosystem. So we have, you know, great lab space. We have free deionized water. You know, all the things that a hard tech startup needs. And then Bob is a advisor that's been particularly helpful as an executive coach and as well as a business advisor at FITSE. So my message today here is that actually nature is not a luxury. Nature is not something that's soft or cuddly. Nature is primal and tough. So the best hunters in land, sea, and air, they're animals. The rock that you see in the top right-hand corner, that is a rock recovered from Antarctica. The bacteria that have been in that rock have been living out of touch for the outside world for, you know, thousands of years. On the bottom left, you see the deep sea vents. You see animals living at crush depths that would crush any submarine. And you see tardigrades who could be launched into space, come back to Earth, be rehydrated, come back to life. Nature is actually extremely tough. And my suggestion to you today is that we work with nature to rebuild the supply chain. So my inspiration is the Primitive Technology channel on YouTube. So it's one guy, he's in the jungles of Queensland, Australia, and basically with his bare hands, sticks, mud, fire, he's taken Australia from the Stone Age to the Iron Age. You know, he's dug for bacteria, smelted it, turned it into an iron knife. And what I want to talk about is cradle-to-cradle design principles. So technology actually functions same as us on vitamins and nutrients, and technology needs technical nutrients. And these nutrients can be found in waste because the waste of one animal is the food for another animal or another plant or another bacteria. And then the third principle for cradle-to-cradle is to replace toxic ingredients with better ingredients. So I just want to point out, if any of you are working in technologies where you know, aluminum, gallium, rare earths, scandium, titanium, chromium, zinc, or vanadium are important, take a look at red mud. This is a very high pH waste product that is found in millions of tons around the world, including many allies, Korea and Japan, and Germany. This is a site in Germany, and one thing I want you to pay attention to is the fact that there is life in that mud that would dissolve any animal. And it is making its living, you know, it's found its resources. So, you know, there is a way to process things that we need from a biological cycle. And Forager Station's focus is oil and gas produced water. So we're basically trashing billions of gallons of this stuff a year. It contains many, many, many critical minerals and could be potentially, if properly treated, also a source of water in the desert Southwest. So why have I pursued the path of electrochemistry? So the main reason is that with chemistry, you get a lot of reagents and a lot of side effects. And you know, you try to change the Rubik's Cube one way, like all the squares change around on you. With electrochemistry, you can solve the Rubik's Cube one element at a time. You can use electricity to help you sort and move against entropy and target specific elements. So you can target a specific process one element at a time until you fully unwind this waste resource. So yeah, I want to show you just sort of our Forager Station membrane and process. So instead of using acids and bases to manipulate lithium, we have material which lithium can pass through, nothing else can pass through. And with magnesium, we also have a set of membranes which can be used to refine into magnesium hydroxide. And we're looking at minerals in the toughest environments. One lesson that I've learned is, what type of electrodes could survive this type of use case? And actually what I found is that the cleaner the chemistry, the better the performance. So if you look at the top, this is the standard battery. This is NMP and PVDF. So these are some fluorinated compounds. This is the default in like electric cars and other types of batteries. And what we found is that water and synthetic rubber actually outperforms this toxic mess. And today we're in an even better process, which just doesn't require any glue, doesn't require any water. So yeah, basically what I'm telling you is make your batteries cleaner, get rid of the legacy supply chain, target a supply chain that is made here with better performance, cleaner chemistry that will take you farther in colder temperatures, weigh less, not catch fire, and be attritable, and that you can use clean chemistry as a strategic force multiplier. Thank you.
Thank you so much, Patrick. That was a tremendous refresher on chemistry for me, absolutely, because I haven't been in a chemistry class in some time. But what it really made me also think about was it's so much about the component parts, right? We're talking about the elements that make up the elements that make up these critical minerals, these components that are in to use your phrase, from wastewater to a food supply system, right? These pieces that make up the ecosystem. That's so much of what we are seeing tonight is all these component parts that make up an ecosystem and make up a community. And no defense, technology, national security conversation would be complete without the inclusion of a discussion on autonomy. With that, I'd love to welcome Emma Bates to the stage, founder and CEO of Kachai.
Thank you, Margaret. Hello, everyone. As a alumna of Johns Hopkins SAIS, I am class of 2019. I'm very jealous that you guys get this amazing building and auditorium, and I missed it. How many folks in the audience we've already asked who's startup founders, who here has any experience with military strategy? Yeah? Okay, that's a lot, that's good. So that's kind of where this story starts. I'm the founder and CEO of a startup called Kachai. And the word Kachai actually comes from Chilean slang. It means, capiche, right? You feel me, dog? You say it at the end of sentences, keeps everyone on the same page. And that's what our company does for collaborative autonomy. We keep lots of devices. Maybe they're flying around. Maybe they're just doing AI. Maybe they're sensors. Maybe they're effectors. It keeps them all on the same page. And my time at Hopkins, at SAIS, is really where this all started, because this is where I got my strategic education from the American foreign policy departments and the strategic studies departments. I don't know if those still exist or if they've combined us in different ways, but that's what we had at the time. And I started learning about how you needed your strategy to match your technology and your technology to match your strategy. And then I went and worked in and around the Defense Department, DIU, Army Futures Command, CSIS. Tried a stint in a startup for a little while, working for a startup I didn't own, not being in charge, learning a bunch of lessons. And throughout that whole time, I kept seeing the same technological problem over and over again. And the startup that I founded is designed to solve that problem. So I'm going to tell you guys about the story of how we got there. So for those of you in the audience who don't have any background in military strategy, a quick review being, we're really trying to get away from having like 5 aircraft carriers and a couple of really expensive airplanes to having millions and millions of small things that all work together in real time, that kind of swarm, right? And the reason that we're doing that is in part just because, you're spreading out your risk, right? But also because we need things to be autonomous and able to function and adapt to changing circumstances. And the best way to do that in a composable fashion is to have lots of small pieces. But it's been hard. So for example, drone swarming. If the fusion, I just hear this all the time in my whole career in defense modernization. Yeah, swarming would be great, but if the fusion node goes down, or if the ground control station goes down, or the connection back to it goes down, the whole thing falls apart. It's not a swarm anymore. Forward deployed teams, they need to have a common operating picture. They need all of their devices to be showing them the same truth. Otherwise, one of them might be marching in unsupported by the others because they don't know that he's gone in. And I would hear over and over again, our common operating picture, it's not common, it's that guy's operating picture. It belongs to that one, central person. Forward operating bases, they would love to have, a common operating picture across even just one side of the base to the other. They would love to have high availability and consistency across all their systems. They would love for it to feel more like how we use the cloud, right? But low bandwidth and high latency. Missile defense, same thing. In order to compare what you're seeing across multiple different systems, they have to be able to know that they're looking at the same thing in real time. These are all really the same problem. They want a single source of truth without a single point of failure, right? And let's focus in on collaborative autonomy to kind of illustrate how we took this problem and found a solution. Let's say we're talking about drones flying around. You have 50 drones, and you want them to be able to go off and do something useful without being babysat, right? And you need them to do things together that amount to more than the sum of their parts. So maybe they're lifting a child out of a burning building. Maybe they are mapping a disaster zone and telling first responders where to go, creating their own mesh network when there's no connectivity, there's no comms, doing things that are solving problems for people. And of course, in warfare, if you're attacked by a swarm, you'd better have a swarm to counterattack. So what do you need? First thing, network. Then you gotta be able to talk to each other. A and B and C all need to be able to literally send data across some kind of medium back and forth. Cool. We've got a lot of startups that are doing great things on that. There's a lot of network solutions. We've got that covered. So that's not the problem. That's not why these problems have been showing up, right? That's not the core thing. What's the second thing you need? Interoperability. These are dongles, if you can't tell. A, B, and C need to be able to understand each other, right? That's easy to understand. Plenty of startups are working on that. It's an understandable problem. Let's say we solve that. 3, intelligence. They have to be saying the right things. They have to make sense. They have to be making correct decisions based on good information. AI goes here, right? If you've got an AI solution, it probably is part of that problem solution set. But let's say you have all 3 of those. And they do. They have all 3 of those. And still, collaborative autonomy is not happening. And it's because there's a 4th problem. And that is your system. How do A, B, and C relate to each other? Is A in charge or B? Are they all just independent and sort of really intelligently predicting what each other is going to do next? I mean, what happens if, 5 drones have to defend people from 5 incoming drones? What if they all decide to attack the same one and then there's 4 left? So, individual, that doesn't make much sense. You put 1 in charge, okay, well then you've got a single point of failure. So that's really the problem that has been plaguing this technology modernization strategy world. And I'd sort of described a little bit before, but it's really between centralized control or distributed control. Do you have a queen bee or a ground control station that's in charge? Or are they able to sort of act like the arms and legs of the same being? Can they act as one? Can they be a hive mind? But oops, all queens, right? I spoke ahead of my slides there. Basically, here, the rest of my talk is, this is the kind of problem where if you solve it, you win the next war so much that it doesn't happen, right? Because if you can imagine, if you have defenses and they're designed for things that are working individually, those defenses don't work against things that are using a hive mind, right? And what I worry about is, what if the other side kind of integrates a solution before we do? And I know that that's possible because we've done it. We've figured this out. I'm not really here to plug my company, but what I want to say is, if you're a startup founder, or if you want to be a startup founder, some of the most exciting work that you can do is stuff that people don't think is possible, haven't figured out how to ask for, and don't realize is the fourth piece of a problem that people have been trying to solve, right? Find that fourth problem when the first and the second and the third are like, people are really, they're all talking about it, it all makes sense there, but they don't even know that there's something missing. They don't even know that there's something much more advanced that could be out there. It's a hard road it's really plowing the earth with your face, as a lot of defense and dual-use tech startups are. But it's incredibly rewarding, because what you get to do is stand in front of people and teach them something, right? So who all thinks they maybe learned something new today? Maybe from me, maybe from the guy before, right? That feels great. So here's what I want you guys to take away from this. Strategy is important. Technology is important. Your technology has to match your strategy. And sometimes new technologies completely disrupt the way that we're talking about strategy, and sometimes strategy is reaching out and asking for new technologies. Find that place, because I can tell you, it's so much fun. Thank you.
Thank you, Emma. Again, these component parts, these elements, these pieces that are underlying and backing all that we're working on, all that we're doing across this technology ecosystem and across these founders. So to go from autonomy, talking about how things work in the field, who's in charge, how they communicate, and the communications behind how people communicate is a fitting next topic for us. So I'd love to welcome Alex Martyr, co-founder of Reveler Networks, to the stage to talk to us not only about how communications work, but how we should be communicating.
All right, thank you. Yeah, I'm Alex Martyr. I'm the CEO and co-founder of Reveler Networks. I'm also a professor of computer science at Johns Hopkins, so I'm very excited to be here. I'm going to talk about how we as a company are trying to cross these quote-unquote valleys of death. So there's lots of valleys of death out there. Pretty much every topic has a valley of death or multiple valleys of death associated with it. This here is the valley of death that's in the charge of the Light Brigade. Obviously, the original comes from the Psalms. Our valley of death is trying to transition academic research to a commercial product. And I'm going to take you through our valleys of death, which are really these two different transitions. One where we have to go from academic research to a commercial entity, and then from the commercial entity to actually getting something procured by the military. So everything comes back to this problem for us, which is there's a real security problem here in the United States, but there's a real problem all around the world. So we've seen over the past several years, and it really came to the fore in the last year, that China is determined to listen to Americans' phone calls. They have targeted military, politicians, business leaders, journalists, law enforcement. Basically, everyone who might be interesting to them has been subject to their attempts to listen in on our communications. What's become clear in the last 5 years as well, our government has revealed that actually they don't need to try to get into our cell networks to listen to phone calls. They can actually listen and eavesdrop on communications all around the world. And they can do this because they've placed back doors in the equipment made by Chinese cell equipment companies. These back doors are long-lived. They're likely put there in coordination with those companies, and it allows China to eavesdrop on communications all over the world. Our solution originally comes from an NSF Convergence Accelerator program. This was actually funded by what's now the Department of War, DOW. It was in collaboration with a bunch of other universities. And I wish that I had come up with this sort of problem, but actually this was gifted to me by our program manager. He basically got on the phone with me and said, Alex, I just got out of a meeting with the Director of National Intelligence. He said, we need to figure out what the hell is on those cell towers all around the world. Can you figure that out? And I said, sure, as long as you give us money. So he did. He gave us money, and we went after this problem. We solved it. There's no message in the cellular protocols that tell you what you're connecting to, but we have classifiers that can figure this out. We can do all of this on a phone. You can see the picture of me holding a phone in the Bahamas, connecting to both Huawei and Ericsson. And so, okay, we had this great, successful, academic project. We were then told by the DOW office, the Future G office funding our work, that we really need to get this into the warfighters' hands, and that this really can't happen as an academic project. We need to transition it to a commercial entity. So this is the first transition, the first valley of death we needed to cross, and this is all done in partnership with JHTV, who have been enormously helpful. We were faced with this key question initially, which is, are we going to go after venture capital? None of us are wealthy enough to just start companies, out of our own pocket. Are we going to go with venture capital, or are we going to try to bootstrap with DOW contracts? There's no theoretical reason we couldn't do both, except that we have very limited time. So either I'm going to spend all my time pitching as many VCs that will listen to me, or I'm going to spend my time trying to get contracts from DOW. And we basically made this pro-con list for each, and I found this on my desk a few weeks ago, so I thought it might be interesting to share. There's no guarantee I thought about this the right way. So if you're thinking, wow, he really doesn't know what he's talking about, that's probably true. So the first thing was, we thought that venture capital would let us get a minimum viable product ready quicker than bootstrapping with the DoD contract, and this is because we thought that VC would give us more flexibility with what we do. We didn't know which one would help us actually get to a procurement contract quicker. We didn't know who would have better connections and who would be more helpful there. Again, we thought VCs would be more flexible for us, so we could use the money where it was most needed, potentially outside of developing technologies. There's other things we need to do as a business, and so maybe hire a salesperson or something of that nature. So we thought maybe VCs have an edge there. We felt very strongly that working with a DOW office would help us get the requirements from potential customers and end users within the military. And this is because they're sort of naturally connected with those groups. All of their sort of money is designed to help those potential customers. They're not the same as the people who actually buy things, but they're the people they buy things for. We also obviously thought this was probably lowest on our priority list, that we could have the chance to increase our value before we take any money by bootstrapping with DOW. So that's right, anyway. Ultimately, we decided we wanted to bootstrap with DOW contracts, and the reason is we didn't want to develop our technology sort of in a vacuum. We wanted to make sure that whatever we're developing with the limited amount of resources we have, that it's very well aligned with what the military customers actually need and what would provide the most value to the warfighter. All right, so we got our contract with DOW. We now have a couple contracts with DOW. And this allowed us to add a bunch of new capabilities and features to our technology. So I'm basically going to tell you why I think this, I don't know if this was the right decision, but why it was probably a good enough decision for us. I have no idea if the other way would have been better or not, so let's just pretend this is great. It turns out that the Future G office, who's funding our work, our incentives are aligned, which basically means we both succeed if our technology gets adopted and gets into the hands of the warfighter. They get more money from Congress, we get money in our corporate bank account. That means that they've helped us, they've been enormously helpful with getting trials going with different military groups around the world. I asked them, I'm not exactly allowed to say which of them are trialing it, but we've got 4 trials going on right now, and all of these can be turned into actual like small procurements. These trials and getting connected with these military groups has led to a bunch of new features getting added. Some of these were very small features that we just didn't think of. Others were a little more time consuming. But basically the product that we have, the phone apps, and we do this on hotspots, we can do this classification on a bunch of different devices. All of these are now tailored to what these groups need. And they're also helping us grow, probably not as quickly as venture capital would, but they basically came to me and told me, your company needs to grow. We're connecting you with all these military groups. You can't be a company of 5 people anymore. So they basically gave us $500,000 more to go hire a couple people. They've given us, they're basically helping us grow. We're hopefully going to be about 10 people in a couple months. So that's, right, so this takes us sort of to the second transition. This is still where we are. We have not crossed the second valley of death. I don't know if we'll ever get a procurement contract, but I have reasons for optimism, which is that we have promised you, this is Sisyphus pushing the rock up the mountain. We have promising trials with DOW groups and with the Department of Homeland Security. We met with PEO Soldier, which is the big procurement office for the Army. They think we're a fit for their requirements. They then all went on furlough with the shutdown. So anyway, we have obvious reasons for pessimism. One, we're a startup, but that's true for all of us. DOW has very deliberate and slow purchasing cycles. That's on purpose. You know, people's lives are potentially at stake. That's kind of annoying for small companies. We have to stay capitalized until we can actually get through that cycle. That's led us to think about diversifying. We have new contracts with DOW, hopefully 2 to 3 more contracts in the next year for new product lines, all in the cellular security space. And ultimately, we want to pursue a dual use for this. We think getting traction within defense can help with corporate communication security. So thank you very much for listening to me. It's great to be here.
Thank you so much, Alex. What I really appreciated about your talk, as someone who's been on both sides of the equation as a founder and now as a VC, I really like that chart a lot. I saw some people take pictures of it. I think that's a great encapsulation of sort of the differences, the pros and cons, the evaluation. And what's really interesting and stood out to me is the focus on alignment. And that's actually a big part of, even though we're going to hear from our next speaker, a deep dive into microelectronics, I'll have to say it is extra special for me as one of the team members at Squadra Ventures who actually invested in the next company that you're going to hear from, because it is so much about those pieces behind the scenes. Just as microelectronics power everything that we do, everything that's in your hand, every camera we have, there's also many people that must be aligned to power companies and founders. With that, I'd love to welcome Edgar Garay, founder and CEO of Falcom, to the stage. A lot of personality with this one. Keep the claps going.
Awesome. And one more. Oh, hold on. Yes.
Thanks, friends.
Awesome. Well, super excited to be here. This is super cool to be sharing all the technology and our journeys as entrepreneurs. So my name is Edgar Garay. I'm the founder and CEO of Falcom. So we're a fabless semiconductor company. I'm going to tell you a little bit of my story, and I'm also going to talk about the cool technologies that we're developing, why we're developing it, and the impact that it's going to have in the world. So a little bit of my background. I was born in Venezuela, grew up in Colombia, and then moved to the States in 2001. I have a PhD from Georgia Tech. I think I'm the only non-founder that is not from Johns Hopkins. Falcon was incubated by Berkeley Skydeck, and I've been doing Falcon for 4 years, and we've built an amazing team, amazing technology. We've raised close to $11 million in VC funds, and we're building dual-use technology, dual-use microchip technology for wireless communication, defense, and EW. So the main thing that we're focusing right now is on power amplifiers. Whether you guys know it or are aware of this, you probably use hundreds, if not thousands, of power amplifiers a month or a day. Power amplifiers are critical for wireless communication. They're the microchip that goes behind the antenna and injects enough power so it reaches the intended target. Historically, these power amplifiers are super energy inefficient, so they're very power hungry. And this creates a lot of thermal challenges and energy budgets. And it's really hard to create new systems, new satellite communication systems, radars, and anything that transmit energy over the air. So that's one of the critical components that we're redefining. And we did this by creating a new architecture that's more energy efficient and that it performs extremely better than commercial components. So this is an example of what happens when you increase the energy efficiency of a wireless transmitter system. When you go from 30 to 50%, it seems like a small incremental increase in efficiency, but what happens is that you reduce the power consumption by 40%, and you also decrease the heat that you're generating by 2.5x, right? So this is incredibly useful for people that are building next-generation satellite systems, next-generation communication systems, EW and radar systems as well. That graph that you see there, it's the comparison of the energy efficiency performance of the architecture that we're commercializing as compared to what you could buy off the shelf today. So it's a huge increase in the energy efficiency. So how does this translate to better systems for national security and mission-critical systems? Well, if you talk about, let's say, tactical communication radios, one of the main issues, I spent a little bit of time working at the Army Research Lab, and one of the main issues that we were trying to figure out was how to reduce the battery load that the soldiers carry. Sometimes they carry up to 40, 50 pounds of batteries, so creating more energy efficient system means that they can reduce the amount of batteries that they can carry around the battlefield. Not only that, but you can increase the performance of radar systems, increase the accuracy. So in a way, increasing the efficiency of the power amplifier can give you a better tactical advantage, right? And we see these across, again, radar, EW, and communication systems. So a little bit of my journey and my personal journey. I finished my PhD in 2021. I actually ended up graduating in 2023. But I spent around 10 years as a grad student kind of trying to look for an idea that could translate into building a company. I've been studying startup for the past 20 years of my life. I was a solo founder, and I was really interested in building technologies, building teams, and creating a difference in the world through technology, right? So the first 2 years as a solo founder, I don't know if for those of you that are earlier in your journey, it was, as a solo founder was a little difficult, but I've seen that's how building startups work, right? You have ups and downs, but one of the main things that I've learned is that momentum and keep on keeping on, as I like to say, it's kind of one of the key things that you have to work on as you build your startup. So we're based in Atlanta. We're a team of around 15 people. As I've mentioned before, we've raised close to $11 million, and now we're doing a Series A and working on really cool commercial projects and developing other cool pieces of technologies. This is an example of the products that right now we're commercializing, and this is an example how we went from university lab, research level microchips to high volume production, right? And to do that, we created a lot of partnerships with foundries, specifically global foundries. We also built relationships with assembly houses, packaging houses, and we did a lot of third-party validation. So it wasn't an effort that only was Falcom alone, but creating a lot of useful partnerships. It's key in developing advanced technologies. The picture that you see there, it's an evaluation board that currently we're sampling to customers, and it's a product level microchip. So just to think about, I don't think that a small team of 10, 15 people could do this 20 years ago. So I think the industry has changed in a way that now small teams that are agile and fast can create high-performing semiconductor products that can outperform whatever is commercially available. So another thing that now we're working on is on the design flow and the software tools that you use to develop semiconductor products. So one of the things that we realized through our journey is that it takes a long time to develop semiconductor products, specifically power amplifiers. It can take up to 2 years to develop, meaning that you have to do a lot of 3D electromagnetic simulations, you have to do a lot of nonlinear transistor simulations, you have to put all that together, and sometimes when you manufacture and you get it back to your lab and measure it, the hardware to simulation correlation is not there. So you have to do it all over again and all over again until you get the right technical performance, right? And the main thing about that is that when we create all those data in terms of simulations and performance simulations, and after the product is done, we throw it away. We don't learn anything about it. The designer and the engineer builds a better design perspective, but as a company, that's kind of thrown away, right? The designer leaves, the expertise lives with the designer, right? So one of the things that we're trying to figure out and we're currently working on is how can we build foundation models and use AI to build products that pass all the manufacturability rules, but where instead of 2 years, it can take us a month or less than that. So I want to show you this because we haven't shown this publicly, but this is the first PI that we designed using our AI tool that we're calling Gandalf AI. The main element that we use in our PAs is gallium nitride, so therefore Gandalf AI. So the red curve, it's 4 months of development using a team of 3 people. Blue line is 10 minutes of development. And I just want to tell you that the blue line, it's complying with all manufacturability rules, meaning that it's a product that is ready to sell. And I want to just kind of pause here for a few seconds because we do believe that this tool and these efforts are going to change the semiconductor industry on the RF domain. On the digital side, people have been able to do this 10 years ago, but when it comes to RF, because of the nonlinear behavior of the transistor, the electromagnetic performance of the metal layers and the metal stack, it has been impossible. But we figure out a way where now we can build a product catalog of hundreds of products with a small team in a few months. And that's our goal now, right? So super high performing power amplifiers that be commercially available amplifiers, but also doing them quick and building the product catalog really quick. So these are our main focus areas. So we're building PA products, we're building electronic design automation tools, and also we want to bring manufacturing and testing here. We want to vertically integrate. 80% of packaging of microchips is done outside the US. Why? There is not a reason that we couldn't bring that here. And that's kind of one of our goals. This is the amazing team that is, because all of this is happening. One of the things that I learned is that building amazing teams It's one of the key components in creating great technologies and creating great technologies. These are some of the lessons learned. The main thing that I'm going to say is that, I hear no probably 2-3 times a day. So in the past 4 years, I probably heard no thousands of, times. So get used to it. Love the word no. And if you do that, I think you can do whatever you want. So follow us. We're hiring. Follow our journey. We're building really exciting technology, and I think next year is going to be amazing for us. Thank you guys for your time.
Thank you so much, Edgar. So, that one's extra fun for me because I have actually had to be in the seat to say no to Edgar at times about different things, so it was uncomfortable. But I'm glad we can share that moment, that we are, that it's all good, and it's part of the journey. And I think that that's a big piece that you've heard from all of the entrepreneurs tonight, and that you'll certainly hear from our last story tonight as well. So the one thing that I want to say as we head from microelectronics, the piece that's really standing out is sort of how all of these things, how do we actually, we've been hearing the stories of how people make things, how they come together, how they get it done, how they build things. And most importantly, the theme across this that really hits our national security conversation tonight is how do we manufacture it? How do we make it not only the team and the technology, but how do we actually make hard things here in the United States? And with that, as we started our conversation focused on Earth, we're actually going to take a quick trip to space. I'd love to welcome Warren Su, co-founder and CTO of NDocs, to the stage.
Good evening. My name is Warren Su, co-founder and CTO of NDocs. Let's start by imagining a scenario. It's 2026. The Chinese People's Liberation Army invades Taiwan. The world's most advanced chip foundries go dark. The Chinese Navy sets up a blockade around the island. 20% of global trading routes are cut off overnight. Your next iPhone upgrade, scrubbed. Your ChatGPT, offline. But this crisis goes far beyond semiconductors. For decades, the United States has offshored its manufacturing, making us reliant on Chinese supply chain and cheap Chinese goods to maintain our economy and current quality of life. From metals to chemicals to something as simple as textiles. Any break in that chain will make us look weak in front of our geopolitical adversary. The fact of the matter is, the US needs to reindustrialize for national security. Setting the catastrophic 2026 scenario aside, my journey to tackle this problem started with 6 days. That's how long it took for Uncle Sam to approve my green card. You see, I emigrated here from Taiwan with the conviction that America, more than any other place, is where you come to build things that matter, especially when the stakes are high. My passion when I first came was to build spacecraft. My first company, Squid 3, manufactures specialized thermal blankets that are not supplied to other space companies. And that experience became my crash course in the American industrial base and the problems it faces. I saw firsthand how lagging the supply chain was in the United States. Lead times of 6 to 12 months were the norm. And I wanted to know why. So earlier this year, I joined a group of startups as part of the Defense Innovation Unit's Defense Tech Accelerator. We toured Army depots and family-owned machine shops across the country. And what I saw was both inspiring and alarming. Inspiring because these facilities are filled with skilled artisans who have dedicated their entire lives to making things that keep our nation safe. And alarming, because the workforce is aging out faster than it can be replaced. And so much of that expert knowledge lives only in their heads. It's not documented, not in SOPs, not in any manuals. When this current batch of artisans who know how to run the legacy machines and crafts retire, that knowledge walks out the door with them. It's gone forever. Now, everyone in DC has been talking about reshoring for quite some time, but why is it so hard to do? The answer is simple: people. These manufacturing jobs are often done in loud, toxic, and hazardous environments, and they're not that desirable to modern Americans. Most Gen Zs definitely don't want to work in a factory. Making offshoring the only options Americans have until now. As a civilization, we have built specialized robots that do one task extremely well, the kind you see in car assembly lines. And now we're chasing humanoids, general purpose robots that can fold laundry, cook dinner, and even walk your dog. But the future, the next decade, belongs to a new class, specialized humanoids. And here's my thesis. Factories today already hold millions of dollars worth of production equipment, CNCs, laser cutters, sewing machines, all perfectly operational. It makes no economic sense to just rip them out. So instead, the path to 100% automation is teaching a humanoid how to operate them the same way a human would. And that's the physical AI solution we're developing at NDocs. We fine-tune humanoids to operate existing machines in military depots and factories. Robots that learn not from codes, but from observing skilled artisans, pressing the same button, pulling the same levers, and loading the same materials. And that's how we started bringing manufacturing back to America. For the near term, we're focused on capturing decades of tribal knowledge in a multimodal fashion, fusing egocentric videos with audio and tactile data. We turn this knowledge into training data for large language models that govern robot actions. And this approach will preserve billions of dollars in existing CapEx and makes manufacturing AI accessible to everyone. It shifts competition away from a cheap labor race to an AI race, a race that the US must lead like it did in the space race. I came to the United States under an immigration pathway granted to extraordinary individuals. And to me, that carries an obligation to contribute to the national security and technological leadership of this nation. When people think about national security, they tend to picture soldiers and tanks, but I see something else. American engineers, scientists, and founders. People who choose to serve not with weapons, but with ideas. That's why I co-founded NDocs alongside Army veteran Blake Doherty. We already have an ongoing pilot program with to modernize a 90-year-old Army depot under a US Army SBIR Phase 1 contract. We're building robots for national security. And if you have the vaguest interest in the stability and future of the US, you need to see this as your mission too. We're calling for motivated talents to join our team in Boston because protecting our freedom and way of life isn't someone else's job. It's ours, all of us. Thank you.
Thank you so much, Warren. So across the evening, we heard a call across many missions, across many ways that scientists, technologists, we're bringing technologies from the lab to the field, and tonight also to the stage. We've gone from critical minerals to autonomy, communications, microelectronics, a brief trip to space, and manufacturing. And all of these things are critical as we move forward. To put it all in context, I'd love to welcome my colleague, Dan Madden. Oh, full clap. Yes, let's get a full clap for Dan on the way up here. Dan Madden, who's our principal for national security at Squadra Ventures, who's had a lot of perspective on this and who has had an opportunity to see this at all angles.
Excellent. Thank you. Really big picture of me. Okay. All right, I'm going to tell you a big story, a little story, and a little bit about funding and founding, and I'm going to do it all in just a couple of minutes so you guys can get out of here. Big story. So the U.S. has been a science and technology superpower since after World War II, Vannevar Bush, and the founding of the National Science Foundation. Since that time, we've gone down from the U.S. government, not the United States, but the U.S. government providing about 50% of the funding for research and development globally, down to around 5%. And a lot of that's great, right? Like a lot of that funding is now being provided by our friends and allies, by the private sector. The challenge that today, it's no longer just our friends, allies, and other capitalist democracies that we're competing with. It's also an authoritarian variant of capitalism. And so it's not just good enough anymore just to be a part of developing great foundational technologies. Today, it actually really genuinely matters for our society, for our lived experiences. Who owns the platforms that our economies are based on? Now, like a smaller version of the story. So my background, when I started off my professional life, I was in the Marine Corps. I remember when I got into the Marine Corps, they handed me a GPS receiver. And that thing was about the size of a textbook, right? And it didn't work particularly well. It worked about 10% as well as the thing that I could go and buy at Walmart. And so that was like kind of like a snapshot for me of what my experience with technology in the military was going to be like. Then I went over started working down the street as a congressional staffer. And this is during the war in Iraq and Afghanistan. I start talking to veterans, constituents that are coming back from these conflicts, amputees. And then I go over to a think tank where I start talking with small unit leaders that are coming back from Iraq and Afghanistan. And I started asking them about the capabilities and the technologies that they're using. I'm like, you guys are getting a lot of value out of these drones that we're sending downrange, right? Absolutely not. Don't even take them with us. Well, why not? And they're unusable. Like they don't work particularly well. They're too expensive. So we have to go and play like dodge the ID, looking for them if they crash, which is not what you want to be doing in Kandahar. And then I go work in the Pentagon. The Pentagon's also referred to as the five-sided squirrel cage, so no, I do not find answers in the Pentagon. So anyway, like it turns out like nobody's coming to save us, right? And so this is kind of getting to the punchline. You have to take agency in your own lives. This is actually what I love about venture, finding a problem that I've got conviction in, a team that I've got conviction in, and putting like capital, network, and our time behind them to help them be successful in crushing the problem. Talking with actually some of the founders that have been presenting tonight, it is a massive leap to step out of the lab and into the market. You're not alone. There are the other people in this room. You have a peer group of founders, and there's some other people in the ecosystem that are happy to help you as part of your journey. So anyway, thank you all so much for coming tonight. Really deeply appreciate it. Margaret, I think you wanted to take the mic.
Thank you. So you're welcome to stay here with us. So we could not be more appreciative of you all spending your time with us tonight. I want to give another round of applause to Hopkins Bloomberg Center for hosting us on this fantastic evening. I want to give a round of applause to Myra Norton and the team at Johns Hopkins Tech Ventures. Another round of applause for hosting this conversation in partnership with us. I want to thank Technically, who is our local tech and media group that you'll all be hearing from in the future, for helping partner with us and sponsor this event as our media partner. And I want to give a huge round of applause again to our 5 speakers. I'm actually welcome everybody back to the stage because you know I'm going to get a picture, for really helping showcase to us what it means to break a boundary. The final thing that I'll say is, I think in many conversations that we get to have with founders that each of you have shared tonight and really have embodied this, is that being an entrepreneur in any sector is relentless, truly relentless. It comes after you at every moment, deep in the middle of the night, first thing when you wake up in the morning. I'm sure you thought of things randomly on the stage here that you have to do next too, but I think it also is an incredible thing to see people who actually are able to be truly present, truly driven, and really stand for something that they're trying to build and something that they're trying to do. And I think that that really is what it means to be a boundary breaker. So thank you all so much. We will see you all out back in the breezeway for a few more bites of pizza, because you know it's a real tech event. We'll hang out a little bit to connect with our speakers and to mingle with everyone in the room as well, to network. We'll close it down at 8:30. So please, again, a round of applause for all of our speakers, a round of applause for yourselves. Thank you so much.